Hi, everyone. Good evening, good morning, good afternoon, wherever in the world you're joining us from. My name is Sharang Thaimade. I represent Seed Global Education, and we are gathered here today on this virtual platform to learn more about this masterclass on cloud computing by Professor Shubhashish Dasgupta from the George Washington School of Business. Thank you so much for everyone who is streaming in. We've got already about 65 plus of you that have joined this session, about 70 now. So thanks so much, everyone joining in. Just to check if you can hear me very clearly, can you let me know in the chat box which city you are joining in from, which city in India, outside of India, wherever you are based. If you can tell me in the chat box which city you're joining in from. There's Shubham from Pune, Mohammed who's joined from Mysore, Bangalore, Hyderabad, Calcutta, Nagpur, Mumbai. Welcome everyone, people from Delhi, Jaipur, Mumbai. So kind of the length and breadth of the country. Welcome everyone. If you are here, please let me know in the chat box which city you're joining in from. We are people from different parts of the world, different parts of the country. Soumya is joining us from Portland in the US. So welcome, Soumya. Good morning to you instead of good evening from everyone in here. Where we've crossed the 100 mark. So glad to see each one of you here. This promises to be a very interesting session on cloud computing by Dr. Dasgupta. I'm going to take this opportunity to quickly give a brief introduction of Professor Shubhashish Dasgupta. He is the program director of the MS in Information Systems at the George Washington School of Business in the United States. He's a certified Scrum Master, and he's an expert in software development, open source software, and cloud application development. Thank you so much, Dr. Dasgupta, for taking out time on this weekday morning and taking us through what promises to be a wonderful session on cloud computing. Welcome, everyone. Once again, we are 120 plus people in the room. Thank you so much for everyone who's taken out time. The next 1 hour promises to be very informative, very insightful, very interesting. Those are the three I's that we like to talk through these master classes about. I'm going to leave this platform now for Dr. Dasgupta. I'm just going to add him on Spotlight, and Professor Dasgupta will now share his screen. And over to you, Professor Dasgupta.
Thank you. Thank you, Sharang. Appreciate that introduction. Let's get started. Can all of you hear me clearly? Good. I'm just assuming it is. So Sharang is keeping tab on that. Let me just get started by sharing my screen. A quick switch into my different monitor. And there we go. Hopefully you will be able to see this in full screen. Okay. Sharon, thank you for the introduction. Once again, my name is Shubhashish Dasgupta. I'm the chair and the associate professor of information systems, and the director of our Master of Science program in Information Systems Technology at George Washington University in Washington, DC. I just wanted to mention that as you explore the contents of cloud computing and digital transformation, and then with Megan presenting something about our programs, some details about our programs, there was a time many years ago, almost 3 decades ago, when I was in a similar position exploring the opportunities, especially for higher studies in the US. And I had come here for my doctoral work in the late 80s, early 90s. And it's an exciting time, and some of you might will enjoy the second part of our presentation as much as this part, which is the cloud computing and digital transformation. Things have changed so much, because when I was exploring it at the time, everything was by mail. There was no Zoom, there was no cell phone, everything was done by mail, and there were hardly any presentations like this that you could go to. Well, welcome again, and let me get started. I will go on. My plan is to go for about 25 to 30 minutes. Actually, it's planned for about 30 minutes. I might finish a little early, it might take a few minutes more. Once I'm done with my presentation, I'll have some time for questions. But in the meantime, if you have a burning question that you can't wait for getting answered, then please put it in the chat. I'm not monitoring the chat, but Sharon can stop me and ask that question. Otherwise, we'll have question and answers at the end. So let's start with cloud computing and digital transformation. The emphasis is on cloud computing, as Sharon mentioned, not on the digital transformation part, given the time restrictions that we have. So we're going to talk about some of the things, provide an introduction to how did we get to this point of cloud computing. Some of it is fairly straightforward. Some of it is history, and history teaches a few things. So we'll get to that in the introduction. Then we'll talk about what is cloud computing, the different types of clouds, the benefits of clouds, and some of the concerns and risks of cloud computing. In the introduction, we'll talk about the history of the internet itself. So the basis of cloud computing, when we think about cloud computing and how cloud computing has developed as a field and it has grown in importance over the years, is the fact that IT infrastructure has changed. The IT infrastructure includes everything that we have done, everything that is included in the IT space in an organization. It is the hardware, the software, and we'll get to that in a little bit. And the entire environment of IT has changed over time. The fact that we had individual computers, big mainframes, all the way up to network computers, to PCs, network computers, and then we moved into this large something called the internet, which is a network of networks, and that enabled us to then put our computers not in our own facilities or own premises, but to put them out somewhere else, called in what we call a data center, and then be able to connect to that and use that infrastructure, although that is not very close to where we are. So we were going to look at the evolution of modern IT infrastructure, and that evolution has taken place over a period of time over the last 30, 40, 50 years. And there have been, times where it was not a continuous process. Everything was not smooth because things changed over a period of time. With the start of the actual launch of the invention of phones, tablets, changed the way we start thinking about how information is provided and in what way is it provided, where is it stored, how is it delivered from a data center to our device. So the IT infrastructure has different components. The different components of IT infrastructure, as we know, are the hardware that we have. These are the computers, the mainframes, nowadays the servers, the software, the networks that are associated with which enable us to transfer information and data from one computer to the other, from one network to the other. Databases which allow us to store information so that they can be retrieved when needed, and records being kept. And IT services, the whole idea about developing more applications, managing the security and risk, and managing data. And all these things, both the devices, the hardware, the software, the networks, which includes the internet, databases, all have contributed in their own way to where we are now. We have a phone, and we have a phone, iPhone, or or an Android phone, and we can call a cab at any time. I can press a button, and then I can determine, I can put down a destination, and Uber will find a cab for me, or any other ride-sharing app will find a cab for me. So these were things that were not possible, as we know, even 20 years ago. So when the internet was developed, at that time, the applications, there was a promise of multiple applications, but not very clear where we would be going with this. But what has happened is, there are entrepreneurs everywhere, and I know India has its own share of startups now, and they are building, they're being imaginative, they're using this hardware, the software, the infrastructure that we have to build new applications that can be used by both consumers as well as used by companies. So if you look at the evolution of modern IT infrastructure, we started off with, and if you look down that list, we started off with mainframes. Those were large computers, and they were used by engineering and accounting departments. And one of the first things that was so-called computerized, as within quotes, as I would say, is the accounting department, especially payroll, was one of the first things that was so-called computerized. Because at the time, the computer was considered the mainframe, the big mainframe was considered to be a large calculator. So what was one of the biggest things that it could do? Number crunching was accounting, was the safest bet, or the most natural area functional area where computers could be used. Then came the mainframe, but with dumb terminals. Dumb terminals in the sense that we use this computer and keyboards, but we were communicating with the mainframe. Okay, it didn't matter wherever the mainframe was located, but it was time consuming and inefficient because we had multi-user then. But the thing was that they were all multiple users using the same mainframe, but using terminals, where terminals with the screen and the keyboard were essentially not processing any information, and it was all being done by the mainframe. Then came a more decentralized time, and that was when we moved on to what's called personal computers, and that revolutionized everything. With the IBM PCs way back in the 1970s, that's when people realized and companies realized that you could have the same kind, not the same kind, but some processing power at the client side, means at the client level itself, and not it doesn't have to be at on a mainframe all centralized. The next phase, the next thing that happened was local area networks. When all these PCs that were independent, working without any connections, were then connected together, and you could then send messages from one PC to the other. That was a big deal. That was the first time that computers were connected together at that level, at the PC level. Mainframes were connected in many of the universities then. Then came enterprise computing, where all these different devices, hardware, software, they're being used to communicate with each other. And then nowadays we have cloud computing, which was a step forward, which was a culmination of all these different things. And we have not stopped here. We keep making progress as we go along. And the next thing might be, grid computing, edge computing. Those are things that might come up later. So we have cloud computing, and that's how we got here. Let's move on. So the growth of cloud computing, if you look at the growth of the internet, the growth of cloud computing is very closely related to the growth of the internet itself. So to understand why we are talking about cloud computing, it's important for us to understand the history of the internet itself. Many of you are familiar with it. I'm going to play a quick YouTube video. This is the only video that I'll play, given the time that we have. Let me try to go ahead and do that. The sound should be okay. If there is a sound issue, Saran, please let me know.
There is no modern world without the internet. Like the Industrial Revolution before it, the internet and the information age it sparked has created a seismic shift that completely changed how we live and communicate, do business, shop, entertain ourselves, and even explore the universe. Though it has become completely ubiquitous, few saw the internet coming, and no one could have predicted its impact. Now we wonder, how did we ever live without it? And can anything ever replace it? The internet has its roots in pure fiction. In 1898, just as telephones were entering American households, writer Mark Twain penned a sci fi short story titled From the London Times in 1904. In it, he predicted a future in which all the world's phone lines were connected and the daily doings of the globe could be seen and shared by everyone across oceans. Using what Twain called a telectroscope, the story's protagonist called up different corners of the world to look at life, study strange sights, and communicate with others. But it wasn't exactly Twain's best work, and the story was largely forgotten. Then, in August 1962, computer scientist J.C.R. Licklider proposed a similar idea of computers that could talk to one another. As director of the U.S. Department of Defense's Advanced Research Projects Agency, or ARPA, Licklider's memos about an intergalactic computer network explain much of how today's internet now functions, including cloud computing. 7 years later, the first message was sent from one computer to another over ARPANET. The communication from UCLA to Stanford was meant to say login, but only the LO made it through before the system crashed. Still, the internet was born that day in 1969. Things sped up from there. In 1971, programmer Ray Tomlinson sent the first email. He also introduced the @ sign. Different networks were tested throughout the decade at research centers in the US, UK, and Norway. And on January 1st, 1983, ARPANET was officially migrated to TCP/IP, or Internet Protocol. A year later, this was the standard for all military computer technology. In 1991, English computer scientist Tim Berners-Lee created the World Wide Web, an information management system accessible to anyone with a connection. In only 40 years, the internet developed from a system that could barely send 2 letters into a network that could return millions of search results containing billions of words in just seconds. In 1994, a Pizza Hut pizza was the first thing ever purchased on the net, and we've never looked back. As computers shrink from our desks to our pockets and wrists, and as the internet connects not only to our families, but our devices, our houses, our cars, and our everything else, all while connection speeds ramp up exponentially, the question now becomes, what could possibly be next?
Okay, that was the history of the internet, at least the birth of the internet, and how long and how far we have come with this.
There is no modern world without.
Okay, let me try it. Okay, there we go. So if you look at the next few slides, I'm going to be just talking very briefly about, and you can look at the graphs, briefly about the expansion of the internet and the number of users, how the number of users have been growing and the number of devices have been growing on the internet. And all this refers to the amount of information that has been provided to the users, to the different devices, and that data has to come from somewhere. And that's where cloud computing comes in. Okay, so although the numbers has been growing up and the penetration has been drastic over the years, if you go back from 2014 to 2020 in this graph, the growth may be slowing. Okay, and if you look at all the different devices here, it shows different the different graphs when the growth of all these different applications. So when we went from what is called the read-only web, when the first internet was created, the emphasis was on static websites, just to provide information. So people would develop HTML static websites. That's when the read-only web came about, means the web came about. But before that, it was primarily used in universities. So it was the read-only web, then it came what we consider to be the read-write web, where you could submit some stuff, and Google was created around that time. And then because to organize information that was available, then came a time, this was the time of the social web. That was when it was the web 2.0, where basically it was a user-generated web. People were submitting stuff. People wanted to provide information on Facebook. They wanted to provide reviews on Amazon. It was the user generated aspect of it. And now we have gone to the path, we want to provide our information in 160 characters or something like that, which is even more of the chunking of data. And if you look at the social web, here is the time where, the things have really exploded. And here are some of the different technologies that have exploded, and from the time that they have been launched to the time where we are right now. Okay. And some of the hardware contributed to, sometimes it's the software that contributed, and sometimes it's the combination of the two that has contributed to this explosive growth of the internet in general. So if you think about it, I'm not going to ask this question in this presentation, but if we take a step back and think about what internet web application has completely changed my life, when do you even remember the first time you used the internet? Which ones do you use the most? And which application is most important to you? If today, if I tell you that I'm going to, if I have to, at random, delete one of the applications you have on your phone or your tablet, which one would you say you can delete? Anyone else, any other application, but do not delete this one. This is the most important one for me. Let's take a step back and think about those things, because we are completely connected in a way to our devices. Because how many of us, when we wake up in the morning, the first thing we do is we reach across our bed and pick up our phone? A lot of us do that. Okay, not the best thing to do, not the best way to start the day, but we all do that. We are almost connected at the hip. If one day, if you do not have your phone, think about what you will do without it. So one of the exercises that I've given for some of my undergraduate students, I don't teach undergraduates all the time, but in one of the basic classes, one time I did it a few semesters, I gave them this assignment, and you might want to think about it and do it on your own. I told them that inform your parents that you are not going to be available because you have an assignment, it's like an exam, for 4 hours. And I told them that what you have to do in those 4 hours is that you have to turn off your computer, your phones, and any device you have, your watches, Apple watches, whatever you have to turn everything off. You can do anything you want, but you cannot turn on any digital device. And then write me a paragraph and tell me how you felt. So it was a wide variety of stuff, and it shows how connected we are to our devices. A wide variety of things came up. One was, the most important thing was, people said, I didn't know what to do with my time. I thought, if I don't have my phone, I just don't know. I can't, watch TV for that long. But if I cannot do anything, I don't know what to do with my time. If somebody said I went to the fitness center, someone said that I just got so bored that I fell asleep. So we just don't know what to do with the time. And there were some other physiological aspects too. Some people said that I didn't know what to do with my hands, because I'm used to having the phone in my hand. I always kept reaching for my pockets, my phone in my pocket, but I then realized that I can't connect to the phone because this is my assignment time. So various interesting things that how we are completely dependent on the devices, and that's a discussion we can have later on. And the number of devices, now we're switching back to the global internet devices, the number of devices that have come up and the number of devices exploding. And it has gone up in a wide variety of ways, but it has been completely changed with the type of when the smartphones came about, especially at the consumer level. And then it was followed by the enterprise level, but it was primarily consumer driven aspects. Okay, now we have the wearables, which are the iWatch and the medical diagnostic stuff, but they are still building on that connection to the smartphone. So let me talk about cloud computing. I have to speed up a little bit to cover some of the material, otherwise I'll just stop in about 10, 15 minutes. So cloud computing is basically a style of computing. So it's scalable. It's called elastic because it provides IT-enabled capabilities to customers, internal and external to the organization, so that they can use these resources to provide applications to customers inside and outside the organization. So the cloud computing characteristics, some of the things we have to remember about cloud computing is that it can provide on-demand self-service. So we can provide the resource, we can provide the IT infrastructure, and then if you want, you can, whenever you want, you can scale up, you can increase the number of machines you want, you can scale down, reduce the number of machines you want, and you can do it completely on your own. That's the self-service part. So how's this different from having servers? So cloud computing, when we talk about, we're talking about servers, things that provide us with the resources, the IT infrastructure and the resources. It could be the servers. If we had in the traditional sense, those servers were stored in a data center in my own facility. Now, if I wanted to increase the number of servers, I had to go out and buy a new server and place it there. That would take us a few months, install it, configure it, and then, then they have the additional capacity. With cloud computing, the scaling of that's called scaling up, the number of servers. Now, if I want to increase the number of servers, I could just add a server very easily because it was all available for me. It's on demand. So if I want to scale up, say, for example, I'm Amazon, I need more computing power just before Christmas when people are buying gifts, I'm selling more, I have more users on my sites, then I can just scale up very easily. And after Christmas, I can scale down. And because I don't own the servers, I'm just renting those servers, okay? So I'm renting the servers from somewhere else. So it enables organizations, so this kind of computing enables organizations to utilize resources very easily. It gives a fault tolerance, it has, you're outsourced that part, it's easy to scale up, and it's easy to scale down. So the cloud computing, the basic concepts utilize the concepts of what is called utility computing. So utility is just like our electricity and our water. So we pay for what we use, right? It's utilities. So basically, if I use more electricity, my meter runs higher, I have to pay that bill. If it's water, the same thing. The same applies to cloud computing. The more I use, the more services I use, the more hardware I use, the kind of software that is built on it, I can actually do that. I can use it like utility. So that's the reason why it just comes under the umbrella of utility computing. So cloud computing provides broad network access, computing resources, and occurs in virtualized servers. So these servers are stored in server farms, and so multiple people are actually using the same server. The physical server is one computer, but there could be 1,000 people using the same computer because it is partitioned into small areas which are mine. Okay, each individual has their own small area. It's almost like a building with many apartments. The same thing, think of a server as a building with many apartments. So a server has many accounts, and each person is actually living in that particular IT space, and that's called server virtualization. So when I'm using it, it feels like I'm the only one using it because it's my home, it's my server, okay? I don't care about the 999 other people who are also housed in that same server. And that's the virtualization part. Okay, so where are these servers stored? The servers are housed in huge server farms and inside data centers. So these are lines of basically stacks, we call them racks, and these servers are stored in those places. And how do you know that it's a data center? I have a number of them close to my home. So when I drive by, I know there's a data center because I'll give you some of the indications that these are data centers, and it's not a warehouse storing materials. Data centers usually don't have any windows. Okay, because I'll tell, and you might want to think about why do they don't have any windows. Okay. Second, they have, and this might give you a hint, they have huge cooling towers, either outside or on top of the data center. And they have very small parking lots because most of it is automated. These huge, something that looks like a warehouse, single floor in most cases, multiple floor in some cases, but they are huge buildings, no windows, cooling towers on top, and small parking lots. Why is that? Because when you have large numbers of computers put together, stacked together in racks, they generate a lot of heat. And because remember, the computers are fans to cool it down. Now think about thousands of computers inside the same building, and they all are running. So generate a lot of heat. So they have to be constantly, the AC has to be running, the air conditioning has to be running to recycle that air, take out the heat, and provide extremely cold air inside so that those computers can run. Because if the temperature goes up, then the computers start crashing. Okay, so that can become a big issue. And then another thing to note is that the computers are basically, they're what we call butted against each other. So the fans are facing each other. So there are aisles. If you think about aisles of computers, there are hot aisles and cold aisles. The hot aisles are where all the hot air is coming in, and that is to be recycled. And there are cold aisles from where the air is coming, the cold air is coming back in. Okay, so cooling is important, and there are employees who use scooters in it. And if you think about it, because there are large numbers of things and there are large distances to be covered, so people use their scooters inside to go from one lane to the other, because it's a large distance. Otherwise, walking will take some time. Different types of clouds that are available. There's a public cloud, which is widely available. It's shared, easily accessible, multi-user IT infrastructure that are available to non-exclusive to any entity in the general public, individual groups or organizations. And the public cloud vendors provide application storage and other computing facilities over the internet. And then comes the private cloud, also known as an internal cloud. So a company actually buys and maintains its own cloud platform. And IT infrastructures can be accessed only in a single entity or an exclusive group of related entities that share the same purpose. So we have our own cloud, but nobody else can. In my organization, if I have my own cloud, nobody else can access that, and that information is available only to my employees and people who have the access abilities. And then comes the hybrid cloud, which is a mix of the public cloud and the private cloud. Then comes the vertical clouds. The vertical clouds are built for different businesses, say based on industry usually. So the vertical cloud is, say, for finance industry, then you could have separate one for the insurance business and things like that. So here is a diagram that actually shows the different types. You have private clouds within the organization. You have a public cloud. You have public clouds like Amazon and Google. And then sometimes you also have a firewall, but you can have a connection between the public cloud. A part of your applications could be in the public cloud and the others in your private cloud. And that is called a hybrid cloud. So some of the cloud computing services, you'll hear these terms when that come about. The one is called the infrastructure as a service, a platform as a service, and software as a service. Most of us are familiar with software as a service. You know, when you have a software available on the cloud, and you can create a login and you can use the software. You don't have to download anything. You can work completely in the cloud. We understand that part of it. But infrastructure as a service, in this, the cloud computing providers offer remotely accessible servers, networks, and storage capacity. They provide these resources on demand and based on the servers that are in the data center. Whereas platform as a service, people rent these servers, operating system, storage, database, and then they create their own applications on this platform. So it's almost like giving them a server. If I would buy a server and store it in my own company, in my own data center, instead of doing that, I'm renting a server from, say, Amazon Web Services or from AWS, and then I configure the server based on the things that I want in that server. I want a Linux box. I want to put Apache. I want to create a LAMP stack for full stack development. I want to put Apache. I want to put MySQL. I want to put PHP on it, and then create applications on top of it. I can customize it as if it's my own computer, but I'm renting it from Amazon. Okay, so those are the different types of services. Here's a chart that compares on-premise software, infrastructure as a service, platform as a service, and software as a service. This figure shows that the customer manages and what the vendor manages. So as you can see, on-premise software, it's all customer managed. And when you go to software as a service, it's almost everything is managed by the vendor, and then comes the ones in between. So what are the benefits of cloud computing? It has a positive impact on employees, makes things much easier, it can save money, and it can also improve organizational flexibility and competitiveness. And some of the cloud computing concerns is the reliability. For example, Amazon Web Services last year had a couple of major outages, and which meant that lots of applications from many different companies went down. There are privacy issues, there are security issues that have to be addressed, and the regulatory and legal environment that has to be taken into account as well, because can you store your data? Are you required to store data within your country? Are you allowed to store data outside the country? Those are the legal things that you have to take into account. And the criminal use of cloud computing is always there. Okay, and we don't even have to get into crypto and things like that. So with that, do you have any questions for me? I'm going to stop sharing.
Thank you. Thank you so much, Professor. Yes, there are some questions that have also come in. But before I move to questions, I have a quick poll question that I wanted to ask. I actually wanted to ask you this before the presentation, but now it should be on your screens right now. So the question that you can see on your screens, there are 350 participants here. You can see this question on your screen as to how would you rate your current understanding of cloud computing and related technologies? I'm sure after this session, people who had something low or average would go into high. So we've got about 50 people who've answered this question so far. I'm going to wait for a minute or so more. The question on your screen is, how would you rate your current understanding of cloud computing and related technologies? We've got about close to 100 people who have responded to this. If you have not responded, click on that poll icon if you're taking this from the phone, and you should surely see that on your screens right now. Great. So I'm going to end this poll now. I've waited for the best part of 1 minute. And as you can see on your screens right now, that about 86% people have that their current understanding is average or high. I think, quite modest is the 62% people who've said that they're average. I'm sure they know a little more than average about these technologies. And certainly this masterclass by Dr. Dasgupta has certainly improved their knowledge in this as well. I'm going to have one more poll question, but a reminder to each and every 300 of you that are in this room, 340 plus of you that are in this room yet. If you've got questions for Dr. Dasgupta, he's going to be here for a few more minutes. So please don't ask the questions in the chat box. Please ask the questions in the Q&A. Anything that's on your mind, Professor Dasgupta is going to be here to answer some of those questions. So click on that Q&A tab and certainly go ahead and ask your questions. But before that, I'm going to have one more poll question. And I'm going to launch that. This is about your interest in studying a master's education in the US. How keen are you to pursue your master's education in the US? If Are you very keen? Are you undecided yet? Are you not very keen? Because we've got Megan from the George Washington School of Business who is going to take you through some of the benefits and some of the resources you will have to pursue your master's education in the US. There are about 80 of you who have already answered, so that's pretty good. One quick reminder, if you've got questions, the Q&A tab is where you must go. There's a poll that's on your screen right now. I've got 95 of you who've already answered this question. How keen are you to pursue your master's education in the US? Just a couple more seconds. I've got 105 people who've answered this question so far. And I'm going to end this poll now. You can see the results of this on your screen. There are about 32% of you. So that's about 32 to 33, candidates who have answered this poll question are very keen to study a master's education in the US. George Washington School of Business could be one very interesting opportunity for you to consider. About 60 of you are undecided. I would request each of you to wait back and hear Megan and what she has to offer, or what GW School of Business has to offer each and every one of you. If you're not very keen, certainly still do stay back. Megan would take you through some of things that you might be missing out on. If you change your mind, maybe you can change your mind and also come into this. So I'm going to quickly stop sharing my screen. We've got some questions in the Q&A tab. Just quickly curate them. Please, this is a reminder for students. If you can click on the Q&A tab, please do upvote the questions. The more higher the votes, I'm going to ask those questions. I'm going to start off with the most upvoted question by Himanshu, who's asking, Professor Dasgupta, could you please take us through a brief description about what Web 3.0 is? If that's your area of expertise, if you can share a little insights on what Web 3.0 is.
Well, there's a lot of discussion about the Web 3.0. It's the interactive web. It's beyond the Web 2.0. I don't think it has been kind of what should I say? It's been finalized yet. It's crystallized yet on what Web 3.0 is. But it is all the interconnectivity, everything that we associate with what we consider to be Internet of Things is going to be part of what Web 3.0 is going to be. Everything that we do is connected, from our refrigerators to our cars to self-driving and cars and things like that, are all part of what the umbrella of Web 3.0 refers to. And that's what I would leave it as a brief answer to it, because we can have a long discussion about it. Thank you.
Sure. Great. Thank you for that, Professor Dasgupta. My next questions, since you are also the program director for the Information Systems, Masters in Science program at George Washington University, I think there are a couple of questions that are coming in through some of the backgrounds that students must have while they, would want to come into the program that has cloud computing as their base. What are some of the backgrounds that you would recommend?
I think any background, we take people from any background. There are students here who, in our program, who come from liberal arts backgrounds, okay, who have done things in liberal arts, for example, in political science, in maybe in things like English too. And then but they've always worked with computers. They've always liked computers, but not done anything in computers. So in terms of their education, and they want to move into to information systems. So it's a wide variety. I have to admit, though, most of our students are either from the engineering background or they are with bachelors of IT. But that does not mean people can't come in from other areas. Okay, most of our international students have a computer science degree or an engineering degree, or even a bachelor's in business administration with an IT background. But people can come in from anywhere, and that's the fascinating the fascinating part of US education. There's a lot of flexibility built in. Yes, if you're moving in from English, or if you've not done anything in the IT space, you will probably have to take some prerequisite classes so that you have the foundation before you can start the actual master's level classes. But that's the only, and we have one foundation class that you have to take in programming. And then after that, you can take. Our courses are very technical, but Megan will go over that.
Great, thank you. I think that answers a lot of questions that maybe Tejas had on how you can start your career from a base level, because there's no real background, mandatory subjects, etc. that was there. I think that was also a question for someone who's come in from a medical background. So I think Joel John had the question about that. So I think that has been answered as well. My next question to you, Professor, is about the intersection of cloud computing and cybersecurity. How can, Arpan's asking, how can we implement cloud computing in cybersecurity? Any tips, any thoughts or any insights you'd like to share about that?
I think that's a very good question. It adds a level of complexity. Security, cybersecurity, cloud computing adds a level of complexity to cybersecurity because everything is distributed. There are some things that you're renting from other vendors. Say you have all your materials or all your data on an AWS server. So it is going to be difficult because although you're responsible for it, you're also dependent on the vendor, in this case, AWS. So it increases the level of complexity in terms of managing it. But it has been done because AWS and major cloud providers have extremely secure locations. Physical security, like I said, all these data centers, you can't enter any data center. There are multiple levels of security because of the physical data that is being stored there. And in addition to that, they also provide firewalls, multiple levels of security, because that is their business. They have to keep it secure. And for us as users, we have to maintain our applications so that there are no open doors for people to get in and hack into our applications. But the rest of the stuff, the infrastructure itself, I think so far has been well maintained. We have not heard about any hacking of the cloud computing services themselves. Most of them are based on the applications. If PayPal got hacked, it was PayPal's basically their own application, not the servers. Yeah.
Okay. One last question for you before we let you go, Dr. Dasgupta, is around some of the career opportunities. There have been questions coming in the chat and also in the Q&A tab about some of the skills that are required and what kind of career prospects are there for people that graduate with, information technologies, cloud computing, specialized focus in the United States market.
Yeah, let me just mention, Megan will talk about it also. Within our MS degree, we also have specializations. We have specialization in cloud computing. We call it a certificate within the master's degree. So you can finish with a certificate and a master's degree at the same time in cloud computing and in artificial intelligence, or a combination of the two. If you don't want a certificate, you just want to take courses both in AI and cloud computing. Now, I'll try to be brief, but what I'll say is that if you're looking at jobs, especially in the US, after you finish a master's degree, it is for individuals who have studied outside let me put it this way, as international students, it is very skills-based. Skills-based, can you do this for me? Can you program in Python? Can you manage an AWS configuration of the servers? And in cloud computing, can you develop cloud applications using a LAMP stack? Now, those are the kinds of jobs that are there. The first job is going to be skills driven. So you should be choosing a skills, a program that provides you with the skills. And a program like ours is a skills driven program. So that is the one that you have to choose. Okay.
Right, great. Sorry, Professor, there was one question because Whale Amaroon had requested this question and he sent me a message as well, that he's a medical student and interested in cloud computing. Is it possible for him to combine cloud computing in healthcare? What is the amalgamation or the intersection between cloud computing and healthcare? I know I've asked this question to you about cybersecurity, but just from a healthcare aspect, if you'd like to throw some insights, Wael Amaroon will be very happy to hear
I
that.
think cloud computing has applications everywhere. So healthcare is just, there is definitely going to be applications healthcare. Most of the data is being stored in the cloud, all the healthcare. Many applications nowadays, especially electronic health records, are now being stored in the cloud. So those kinds of things, applications are already there. So you have to then, there are lots of ways to get into that field. There are from the application development side, there are jobs available in the US, and we have had some physicians who have come to our program, over the years. Physicians with doctors who have come to the program because of the explosion of the applications in the healthcare space, of IT applications in the healthcare space. So that's the reason why, I think that there are lots of different technologies that you can use in healthcare. But the thing is that if you already have a healthcare degree, I would say get a pure IT degree and not a mix of the two.
Great. Thank you so much, Dr. Dasgupta. Thank you so much for sharing all your insights through this presentation and through answering questions in the Q&A tab as well. I'm going to, any final words before I let you go, Dr. Dasgupta? For everyone who is still in here, before I let Dr. Dasgupta share his final words, we've got Megan, who's the Associate Director at Graduate Admissions for George Washington School of Business. She's going to be taking us through a presentation on how you can build your career of studying a business master's in the US, specifically at George Washington School of Business. So hang in there, don't go anywhere. This is going to be an opportunity for you to learn a little more, and also we'll be sharing some special insights on the SEED scholarship as soon as you start this presentation. So hang in there, don't go anywhere. Before that, Dr. Dasgupta, any final thoughts before we let you go, sir?
No, thank you. This was wonderful. I got a chance to talk to all of you, and good luck with everything you do. And if our paths cross again, we look forward to seeing you. And remember to mention that we met here on this virtual platform. And thank you, Sharon and Megan. Thank you. I do have to leave to head back to campus. And thank you very much for the opportunity.
Great. Thank you so much, Dr. Dasgupta. Megan, over to you. If you'd like to share your screen and take us through a little bit about George Washington School of Business and what it has to offer for students coming in here from all over the world.
Sure, of course. I hope everyone can hear me okay. Excellent. Okay, great. I'm going to go ahead and share my screen. All right, so my name is Megan Vanson. I am an Associate Director of Admissions and Recruitment here at the GW School of Business. I'm very pleased to be speaking with all of you today. I see we have people from all over India. I also saw someone from Algeria, which is really cool, so welcome. So I'm going to speak a bit about our various versions of the MBA program, as well as our specialized master's programs, of which the MS in Information Systems and Technology is one. So just to give us an idea of where we are located in Washington, D.C., which is the capital of the United States. On the map, if you can see my cursor, right now I'm around in this area right here. But we are very centrally located. You can see the National Mall, the Washington Monument, Lincoln Memorial, Jefferson Memorial, so also the World Bank, the IMF, the Congress, United States Congress, everything is right in this area. So we're very much an urban campus, and we're very much located in the city where government, where private industry, technology, where all of that intersects. A little bit about our rankings. Our MS in International Business, Master of Science in International Business program has actually been ranked #1 in the United States and #2 in the world by the Financial Times. We've been noted for our diversity. We have our number one in percentage of women in our global MBA program. We have, in addition to a high percentage of female students, we also have a very large number of international students. So we have students coming from all over the world, many students from India to study here with us in Washington, D.C., as well as from students from all over the United States, all of the 50 states. Our global MBA is ranked in the top 50 in the US. Our finance program, our MS in finance, is ranked number 2 in the United States. So a lot of high rankings. The Economist has also ranked us number 2 last year for faculty quality. So we definitely have a lot that we're proud about here at GW. So a bit about the programs that we offer. For international students, we have 2 full-time MBA formats that they can select from. We have our global MBA, which is a 2-year full-time program. And then we also have our accelerated MBA. We have various master's degrees in accountancy, finance and applied finance, business analytics, human resource management, information systems technology, international business. We have MS in management, marketing, project management, sport management, and tourism, hospitality, and event management. So a lot of different options. As Dr. Dasgupta mentioned, we also have 20 plus graduate certificates. So our MS in interdisciplinary business studies is actually a degree where you would pick 2 graduate certificates. And for various of our other master's degrees in our MBA, you can use your elective credits to earn a certificate of your choice so that you graduate not just with the master's, but also with an elective. I also want to point out about the little asterisks that you see next to some of the programs. That indicates that the program is STEM designated, science, technology, engineering, math, or that it has a STEM track. So once you graduate from a program, a degree program in the United States, you are eligible to apply to work in the country for up to a year. If the program you're graduating from is STEM designated, you can actually extend that for up to 3 years working in the United States. So for our global MBA and our accelerated MBA, you can choose just the non-STEM version, or you can choose the STEM version. And then our other STEM designated degrees are project management, interdisciplinary business studies, if you choose 2 certificates that are STEM certificates, MS in information systems technology, business analytics, finance and applied finance. Accountancy, I want to point out, has a STEM track. So our general master of accountancy is not STEM designated, but if you apply to the master of accountancy with a major in accounting analytics, that is STEM designated. So an important designation there. But yeah, these are all the variety of programs that we offer at the School of Business. So definitely something to fit whatever interest or career motivation you have. And yes, as I mentioned before, highlights are our world-class faculty, our innovative curriculum, which you got a taste of with Dr. Dasgupta's presentation. We have a big focus on experiential learning here, a lot of case studies, projects. For our global MBA students, they're required to do the Consulting Abroad project. We also have a global and experiential education office that's devoted just to School of Business students. We have a dedicated career center for our School of Business students. And we also have various industry clubs, events, organizations, and a very extensive and involved and global alumni network. As Dr. Dasgupta and I have mentioned a little bit as well, Our programs are very flexible and customizable. We have a variety of elective classes that you can use. So you can, for example, choose to use your 12, if you have 12 elective credits, you could use those to get a graduate certificate. You can transfer into your degree up to 6 credits from an institution outside of the School of Business. We also have joint or dual degrees. So for example, you could get a dual degree in, you could get a dual MBA and Master of Human Resource Management, or a dual MBA and MS in Information Systems Technology. We have short-term global and domestic study away opportunities, and also semester-long exchange opportunities overseas if that works within your schedule. And again, obviously, students entering a graduate program are also very focused on what's going to happen after that and their career search and their career plan. We have the Fowler Career Center here, which is devoted solely to School of Business students. They encourage students to meet with one of their career counselors early on in their academic journey. And they are there to assist students with interview preparation, resume writing, reaching out, making connection with alumni in a similar industry, etc. We also, of course, do a lot of industry interviews. Deloitte was here a couple months ago doing on-campus interviews with students. So it's really a key advantage of being in the School of Business. And just a sample of where some of our School of Business students have wound up after their programs and are working. As I mentioned, in Washington, D.C., we really are here where government, private industry, nonprofits, international government organizations, where all of that intersects. We're very closely located to, of course, the IMF, the World Bank, the Inter-American Development Bank, all of the US government agencies, all of the major consulting firms, Big Four accounting firms have a presence here. And we are a growing hub for private industry as well. Amazon now has a large office in the DC area. There's pharmaceutical companies, a lot up in Rockville, Maryland, just north of DC. So really, any industry you're interested in going into, there is surely an opportunity for you here in the area. Alumni Network is, of course, active in various countries all over the world, including India. So wherever you wind up when you graduate, you can, of course, connect and reach out to alumni in that area and connect with alumni who are working in an industry that you may be interested in. So a little bit about our international student admission requirements. For our applications, generally it's the standard, upload a copy of your transcript, resume, statement of purpose. For our international applicants, we do require an English language test score, and this is required for applicants from India. We accept TOEFL, IELTS, Duolingo, and also the PTE, Pearson Test of English. The test scores that you see up on the screen are the optimal score. So for example, if you have between a 90 and a 100 in TOEFL, a 6 or 6.5 in IELTS, or a 110, 115 in Duolingo, you can still be admitted, but it would likely be admission with the condition that you take an English course during your first semester of study. And we also require a transcript evaluation if your transcript is from a country outside of the United States. We will accept an international transcript evaluation from any organization that's a member of the National Association of Credential Evaluation Services. So for example, you may have heard of WES, SpanTran, or ECE. Any of these is fine. You can go ahead and submit your application before you have the transcript evaluation, but that does need to be received in order for your application to be complete and reviewed. And there is an application fee. However, because you are here in the presentation today, I provided an application fee waiver code that's in the bottom right of the screen. So please take a screenshot or write that down. When you have completed your application, you can just hit save and pay and then select that you have a waiver. You enter the waiver code in, and then our operations team will get your application manually submitted. Funding your education. Tuition here is currently $18.85 per credit. Most of our master's programs are 30 to 33 credits. So for a master's, you can expect tuition to be around $56,000 to $68,000 United States dollars. For our global MBA, there is a flat rate of around $117,000 for tuition. Scholarships are available and they are merit-based. So what that means is when your application is being reviewed, at the time of review, if it's decided that you will be admitted, at that time, it's also decided whether you'll be admitted with any merit scholarship. If you are, it will actually state that in your letter of admission, so you'll know right from the point of admission. And it's often given as a percentage. So for example, if you get a 20% scholarship, that means that each semester that you're registered for, 20% of your tuition will be covered by the scholarship. That is the only funding that would be given at the time of admission is the merit-based scholarship. Once you become a student here and if you are admitted and you arrive on campus, there are sometimes graduate fellowship and assistantship opportunities to be, for example, a teaching assistant. So you may be able to if there's something that's open, you may be able to apply and pursue that opportunity as well. As it says on the bottom of the screen, assistantships are posted at the beginning of the semester and new students can apply for any open positions, but we do not package fellowships or assistantships as part of your scholarship. The scholarship offered in the letter of admission would just be the merit-based scholarship. There also are a couple of international loan companies that are very familiar with GW and with our programs that we have had international students secure loans from. That's primarily Prodigy and Empower. All right, and I wanted to keep that brief. So that is my presentation. We are currently accepting applications for the fall 2023 semester, which will start on August 24th. So we hope to receive your application. We will also be having a sort of a virtual open house on Saturday, February 25th, which we will be sending further information out about. I'm going to go ahead. This is our general business school email. So feel free to write with any questions that you have. I'm also going to just stop my screen share for a moment, and I will type my email address in the chat here. That's it. And thank you very much for joining.
Great. Thank you so much, Megan, for taking our time to take care of this wonderful presentation. We still have about 250 plus people in this room. So thank you so much for each one of you who have stayed back. There are some questions that are in the Q&A tab, but if you still have questions that you want to ask about your profile, about GW, School of Business, etc., please feel free to drop in the questions in the Q&A tab. We'll be asking all the relevant ones one by one to Megan. So Megan has also shared her email address in the chat. So if you'd like to reach out to her, feel free to do that as well. Great. So moving on to some of the questions that have been, in the chat box. I think Vaishali is asking a little bit about GW School of Businesses. Masters in Cybersecurity program. Could you take us through, one or two lines about, what are the USPs about this program? Because how to apply for this program, Vaishali, you can log on to their application portal and you can, log into GW School of Business website and gain all the information there. But just if you'd like to share quick insights about one or two lines about the cybersecurity program, that would be great.
Sure. So we don't specifically have a Master of Science in cybersecurity here in the School of Business. What we do have is the Master of Science in Information Systems and Technology. And as Dr. Dasgupta had mentioned, you can do the MS in Information Systems and Technology, and also using your elective credits, you could earn a graduate certificate in artificial intelligence or in cloud applications and information technology. But we don't specifically have a Master of Science in cybersecurity.
Great, awesome, thank you. And I think that answers Kushal V's question also about work experience. So I think there was a question that was, taken by Kush, who was asking a little more that's also, cloud computing related. But what path would you suggest for a student who wants to get into cloud security or cloud computing, as there are a wide range of topics for students and often they are confused about what to start and where to study. So how would you recommend a student, to be honest, to first start their search on what kind of universities, what kind of programs that they would look at, because like George Washington School of Business, there are quite a few universities, there are quite a few programs as well. Sometimes too much information can confuse some students. What's your advice to students that want to start their search for a higher education program?
Well, first is to sort of identify generally what it is that you're interested in studying. I would, for example, if you're interested in studying cloud computing, I would advise that you look up what the universities are that are known for having a strong program in cloud computing. The US is a vast country, and we have universities that are urban, like GW. We have urban universities that are in much more rural areas. So I think it's important to also identify kind of where you're interested in studying. If there's a particular part of the country, if you really want a large traditional campus in a college town, or if you want to be someplace like GW that's more in a city and that's going to have more opportunities for internships, more job opportunities for post-graduation. And for example, our website, our School of Business website at GW, you can click on a program, read about that program, and also see what the required classes are for the program, and what the elective courses are that you would be able to choose from for your elective credits. And also we do this at GW, and I'm sure other institutions do it as well. We offer online information sessions about our programs, generally twice a month. If you just go to the School of Business admissions and admissions events, you can sign up for an online information session about a program at a time that's convenient for you. And there will be an admissions officer who works specifically with that program, giving the presentation. So you'll be able to ask more in-depth questions and get more information that way.
Great. One quick reminder to the 168 of you that are still here. If you've got questions for Megan, please do ask them in the Q&A tab. We're running out of questions because she's answered mostly everything, and a lot of the presentation covered some of the questions. There was one question for the benefit of the 160 plus people that are here. I know you covered a little bit of it already in your presentation, but I'd like to quickly ask you once again, what are some of the concepts you'd like to quickly share about CPT, about OPT, something for students from a visa perspective? What is the difference between a STEM designated program and a non-STEM designated program? I think these are some basic general questions that the 160 odd participants would certainly gain some insights from.
Yeah, of course. Yes, you mentioned CPT and OPT. CPT stands for Curricular Practical Training, which would be akin to an internship. So once you have been in a program, in an academic program in the US for 2 semesters, I believe, you can apply for CPT. This would all be handled by our International Services Office. So if you are approved for CPT, then you're approved to do an internship at a company or organization off of the campus. OPT stands for Optional Practical Training. And that is the opportunity to work in the United States after you have graduated. So you are eligible, if you're approved for OPT, to work in the US for up to 1 year after you graduate. However, if you graduate from a program that's STEM designated, such as if you choose to do the global MBA, the STEM version, or you do business analytics or MS in information systems technology, for example. With STEM designated programs, you are eligible to have OPT for up to 3 years and work in the country for up to 3 years after you graduate. Speaking about work experience also reminded me of something I wanted to clarify, which is a lot of our Master of Science programs are pre-experience, which means that you don't need to have significant work experience to apply to the program. It's fine to apply to the program coming straight out of your undergraduate studies. The MBA is a little different. For our global MBA, we're looking for students who have generally at least 4 years of post-undergraduate work experience. And the accelerated MBA is for those who have, even further work experience beyond that, are more seasoned in their career. So just wanted to make that distinction.
Great. Thank you so much for that as well, Meghna. I think that was very, very well put and super insightful for everyone who picked it up. One question by Kushal Veer has come in. If a candidate can go for their PhD directly after their bachelor's, quick answer, yes or no, do you think that's possible?
For the School of Business, so there is a PhD offered through the School of Business. We actually don't really work with that in the admissions office, and I'm in graduate admissions. That's more specific. I would advise that you contact them directly. I can put their information in the chat.
Sure. Until Megan does that, if there are no more questions, I think we'll be happy to wrap this up as well. So until Megan finds the information on their website where you can get some more information, or we can share that with Kushal Veer as well on one-to-one level. I think that should be helpful as well. So candidates that are interested in studying their PhD, you can log into some of the information that's provided by Megan. I'm just going to quickly share this link once again for everyone. Yeah, so the link is for the doctoral programs, the PhD programs. The link is now in the chat for you to have. Great. So I think we've covered everything. All the questions have been answered. Wanted to quickly thank you once again. Sorry, there's some background noise. I can't really, I hope you can hear me. Thank you to all the 145 of you that are still here. Thank you so much, Megan, for taking our time. And if you're keen to apply to George Washington School of Business, you have Megan's information. You have the information of the university as well. So feel free to reach out to them. And I'm sure they've been very prompt. Any final words before you go, Megan?
Yes, I'm just going to drop one more link in the chat. This is the link to our admissions events. So if you go to this link, you can sign up for our online information sessions about programs. And you can also sign up for one of our online open houses. Our next online open house will be on February 25th. So please feel free to sign up.
Great. Just to reiterate, there's the business.gwu/GW info session. So that's the link. Sign up for any of these programs that you might be interested in, and some of the info sessions that are also very much program specific. So some of you were interested in technology-based programs, some of you in finance and cybersecurity and similar programs. That's the link that you should follow if you want to know more about some of these info sessions. Well, and I think we've spent the best part of 1.5 hours, close to 90 minutes here. So thank you so much, Megan, for taking our time. Thank you so much to each one of you. Have a nice rest of the evening, rest of the day, wherever you were joining us from. It was a pleasure. My name is Sharang and we represent Seed Global Education. Thank you so much for joining in. Goodbye and take care.
Bye-bye.